Okay. So today's discussion will be focused on the chromatography or paper chromatography. The basic purpose of using or dealing chromatography is to identify what type of substances or mixtures are present in the solution. Let's say accidentally you mix up two to three solutions or two to three substances or chemicals into each other, and now you want to separate them like what they are. Obviously, you cannot smell or taste them. So chromatography enters in. So just say you just mixed up two to three eggs into each other, and now you want to separate them. Jadal review is that just place the spot lines on every specific color and and make a standard over there. So why is it? Because everybody have to travel on that particular standard to make the let you know like either this substance is present into it. Let's say if I especially want to focus on that red ink is present in the solution or not. So I will place a standard mark so that that mark could be seen by the people and not by the people, sorry, by the mixture, and the mixture could reach that till that red point. Now also you will be drawing some bottom line so that like solution or solvent would be traveled to that particular stage, and it will be aiding that mixture to travel right from the bottom of the page to the top of the that chromatogram. Now, next thing is going to be how it is given over there. Ways it according to JCE, we will use it to separate mixtures of colored ink. So you can use to separate the mixtures of colored ink for the food coloring. You can separate them. Most of the inks of food colorings are not just made up of one color. So they might contain multiple colors, like mixtures of colors into them. So you can then separate them accordingly. So these are the sample ideas that used to be separated by the chromatography. Now, specifically, paper chromatography is a process in which you can separate mixtures of colorless substances such as sugars, but in order to make that separation possible, or in order to see that either that separation has been done, so you would be advised towards some sort of the colorating substances. They are called as locating agent. Why? Because if that colorless substance got separated, you would be able to see that thing. So that was the basic review of how you're going to take this up. Now, next process is going to be like how you're going to perform this activity. For that case, simply draw a line with a pencil. However, that pencil with a graphite is not recommended because that might leave some spots of it. Somehow, just use a nice pencil that won't be leaving any carbons on that particular image. I mean, it's simply to avoid the impurity in the solution. Okay, now this line should be about 1 centimeter above from the bottom of the page. Why? Because we are leaving that 1 centimeter area free so that that water or that solvent would travel easily. Generally, in a solvent, water is taken because water is a very good solvent, that is an excellent or universal solvent. However, you can take ethanol also. Now, do not use pen as the colors in the ink may mixed up with the chromatographic paper, and that might left over some spots onto it. So simply you have to take special heat so that the pencil should not left over something onto the paper, and the pen is also not recommended because it will left over some spots on that particular page. Next one is I put a spot. You can use a cheap pipette or capillary tube of the mixtures of the dyes. I mean, like you could place either one spot, you could place two spots. Why? Because we are performing this at got separated. So use that liquid mixture and put on some spots right on the pencil. Why? Because pencil line is going to be making up at a standard. You are going to measure the distance traveled right from that pencil line to the final point till it reaches its final point of destination. Now suspend the chromatography paper in a beaker that contains a small amount of solvent onto it so that the bottom of paper goes into the solvent. Wow. Why? Because we are going to pick up the solvent right on the solvent paper, and we are allowing the solvent to travel so that as per its traveling, it will be carrying something that dies along with it. Now, it is important that the solvent is below the pencil line so that the ink or coloring don't just dissolve in the solvent. Okay, I hope it's clear now. Next thing is that put a lid, and that lid, such as a watch glass is there, it will be placed on the beaker so that the atmosphere becomes saturated with the solvent. This process is performed to stop the evaporation of the solvent from the surface of the paper. So the thing is that after being allowing what that chromatography paper to got dumped into got dipped up into that solution or the solvent, after that particular dipping up, when you feel like okay it is done, and now water is traveling right from the bottom to the particular top area and just close the lid. While lid is required to go close up, it is required so that impurity, air, water, any moisture should not interfere with the activity which you are performing there. Now, next thing is that the when the solvent has moved up along the paper, now solvent is going upward to about 1 centimeter from the top. Now remove the paper from the beaker. Why are we removing it? Because now water or solvent has just started traveling. It is just like paper have absorbed some sort of solvent, and now it is going to make the movement of solute possible. It is allowing the dye to travel upward. Next one is that the highest level of the solvent on the paper at any time is called as the solvent front. So basically, highest level, it is basically the point the solvent can reach, it can travel. The final point is called as solvent front. Now leave the paper to dry so that all the solvent will evaporate. Why we are evaporating it? Because all we wanted is to make the solute to what travel the solute or dyes or the sample. We wanted solvent to carry that liquid or dye right to the top of the paper. Once it is done, we will say that okay, now we want that solvent to get evaporated. Okay, after that, this is the point when you are going to make this evaporation obviously possible. So now we don't need the solvent anymore. Okay, next point is that for the solvent you can use water or non-aqueous media or solvent. A solvent other than water could be used depending upon like what activity or what separation you are going to lead with. So a suitable solvent is usually found by experimenting with the different ones. Okay, now getting back to the thing, here is the point number C right below. Okay, so now the dyes that make up the mixture will be different in two important ways. So how you can make that different possible, how you're going to see them. First thing is the affinity. Affinity is the attachment. Affinity they have for the papers, like how strongly or weakly they will stick to the paper. We don't want that affinity to be that greater because it will keep on catching or they'll be acting as a hurdle to avoid the movement of solute. Now, for the dye. Next thing is that how soluble they are in the solvent, which moves up to the paper. Obviously, when the solubility is more than the required level, this is not going to work on because we cannot because the solvent is not going to make like because this will become a hurdle to make this travel possible. I mean, yeah, that. Now, here would be a point number C. It has hardly moved. You can assume that this could be a solute or this could be the sample which is facing quite hurdles to move upward. Why? Now, there could be two reasons. Either it was not very soluble in the solvent because solvent might got unable to carry that dye forcefully, or might be it has high affinity for both the for the paper or both. So if the affinity is too high, It is not a good thing because paper will not let that substance to travel. If the solvency or solubility is really low, it is not going to work either. Why? Because it will not allow that solvent or that dye or sample to travel, even if the affinity or the solubility is too high. I mean, like they are really soluble, it will be again a hurdle. So that was the first possibility when one dye is not moving, when one sample is not covering up a huge distance. These reasons or three reasons could be possible. On the other hand, here is the spot number B. What is the spot number A basically? For the spot number A, it has moved almost as far as solvent do. So basically it has moved as far as solvent does. It must be very soluble in the solvent. So basically it must be extremely soluble in the solvent. Now it do not have much affinity for the paper. So basically they're not going to, I mean, it has also, now this guy is traveling a huge distance. So what is the reason? The reason being is that it is covering a huge distance, and I mean, like it is weaker in affinity, so it is must be very soluble in the solvent. So you can say that the fraction is going to be termed as chromatograph. Okay, so here is the fig. Now, how this fig is going to help us. So far, we have seen that if we place a paper, or if we, I mean, like this is the beaker, we have filled that beaker with any random solvent. You can take water, you can take ethanol, and all that. Right after the paper, you're gonna place a sample line. So this would be the ideal distance from there things are going to travel. Now, the spot number C is mixture of the solution. Next thing, the spot number A and spot number B. I mean, like they are the distance traveled by the. I mean, okay. So let's say this red orange color A should travel this distance, and the point number B it should travel that particular distance. I mean, like any random orange ink. So they should reach this particular point. If not so, there is another way of placing sample right there or right there. Why? Because we would be like, if there is an orange ink, it should reach this point. If there is a blue ink, it should reach this point. So that is how things or dyes are going to make this traveling possible. Next thing is that okay, so now if spot number A is traveling with the fastest speed, it simply means there is a least affinity or with the paper that was called soluble in the solvent. When it comes to spot number B, it is also traveling with a nice distance, so you can say that comparatively it will be having the higher affinity for the paper. That is why the distance covered by is quite lesser. Okay. Now we have closed this lid. Why this wash glass is being closed? Because we do not want that water to enter and impurity to enter this one. So once we will see, okay, now it is going upward. So we can remove this paper. We will let it dry to let solvent evaporate. Once solvent evaporate, we will check, okay, now how much distance is covered by the substance. In this example, a mixture must have contained minimum of the three different dyes. That is the requirement of the experimentation. We say minimum of the three dyes because there could be more. However, at the school level experimentation, you can go with the three dyes. They are going to be enough. We say a minimum of three dyes because there could be more. Okay, so once of the spot is made up of two colored dyes by the coincidence they move the same distance. So you would only confirm this by doing experiment again with the different solvent. Now at that particular point they're saying that okay, if two solvents, if two dyes, if you sample got same final destination or final point, how can you differentiate? You might perform the experiment again, or you might change the solvent because that could be the problem with that. Now you can also use this experimentation to perform various analysis using chromatography to identify the particular dyes in a mixture. If you think your mixture or M could contain four dyes, you can carry out same as experimentation in the same way. idea is the same. Place the unknown spot right there. You can allot one specific point to the unknown one. So this is the standard basically. You should be clear with the standard. So we can say that okay, if there is an ink number one or blue colored ink should be there, it should reach the point number one. This is the point number two for this thing. So that M is the standard for reaching all dyes right there in this way. So if this mixture contains any blue colored ink, it should reach there. Okay. Now, okay. So next thing would be here is the D1. So what we are doing, we are again placing. We are marking it off. This is the cancel line, or you could say that zero line. We place that same four. So we place four spots of the same ink. So this is one, D1, D2, D3. Okay, done. Right after this, after some time, as soon as we feel like, okay, water has just started traveling from the distance, from the bottom, we will remove it from that particular water tank or like chromatographic tank. After that, I'm like, when it contains the D1 would separate, if it contains this orange coloring, it would be separated right there. If it is, okay, so there is no ink of this color available, so there is no, this is an extra thing that would be impurity. Now, if orange color, if blue colored ink is present in the D4, you can see the matchability. When it comes to the D3, it is somehow relatable. Okay, now, that is how we can identify impurity by the presence of, by looking up to the chromatography, because whenever some impurity is not present, some solution is not present, they are going to, they are not going to be matchable with any sample dye. Okay, I hope this is clear now. Now, the next discussion is going to be about the retardation factor. What the retardation factor is, it is something, it is a kind of distance traveled by certain substances from a particular point, which is called as right from the baseline. So, what we are going to calculate, why is it recommended and why we perform this, it is basically required when we want to calculate the distance traveled by each single substance. The definition, the equation given right there is saying that distance moved by a spot from the pencil line. I mean, like that was a fixed point coming for all. So everybody will travel from this distance till the distance moved by the spot. Okay, so that is a bit complicated one. So the simplest definition of this one is, so just simply that. Okay, I'm gonna write it down. Now, what an RF value is, RF value will be equal to, it is the distance, RF is equal to distance travel, okay, wait a second, yeah, distance traveled by solute, travel by solute, you can denote it by X, maybe, that is the X, distance traveled by solute divided by distance traveled by solvent. Okay, so it is denoted by y. So you can say that it is x divided by y, and that is how you are going to measure this distance particularly. Okay, so now this is to be measured. This could be measured for every single substance, and how we are going to perform this. Let's say I have two solutions, solution A and solution B. So, and I would like to measure their distances. So when it comes to the ratio, okay, ratio of component A and B. So when it comes to the ratio of component A and B, the ratio is going to be, yeah. So the particular ratio for the solute A would be 4.1 centimeter. You can take it. Okay. The ratio or simply value or distance covered by the solution or sample B would be 4 point, okay, let's make it 2 point, yeah, 2.2 is fine, okay. That's it, because we made a solution. The solution contained two solute or samples in it, so you got A and B. Now, when it comes to the solvent, who is going to make both of them travel, its distance or would be, or its vector would be 4.7, or let's make it like 4.9. Now, keeping the back same, you are going to take like distance traveled by solution solute A, distance traveled by sample A divided by distance traveled by solvent. We can simply take it that RF is equal to, what is value for A? It is 4.1 centimeter divided by 4.9. It could be any value. I'm not sure about it. It will be random point. Now, when it comes to the point number B, point number 2, it will be RF. RF is equal to distance traveled by B divided by distance traveled by solvent. Again, taking the same ratio, it would be RF is equal to, for B it was 2.2 centimeter divided by 4.9 centimeter. So that is how we can measure retardation factor for everybody else, to measure up how much distance is covered by the substances. So in this way, using this retardation factor, we can measure distance covered by particular substances. Okay. Now let's make it 1.4.1 divided by 4.9. It would be 0.83 centimeter. When it comes to the next value, it is going to be, it is going to be 2.2 divided by 4.9. It is going to be 0.44 centimeter. Okay, so that was it for the this is retardation factor and all that. Okay, so let's see how the remaining task is going to be taught in the book. Yeah, so that's it. When it comes to the four dyes, you can take like values for all of them, like R of this and this and this. After that, this will be the retardation factor. When we took the example of four dyes, you're going to take retardation factor of all the values by using the same procedure. And after that, if it is a point at the conclusion, you have to be careful by using, that is a precaution, by using RF values, as they depend upon solvent use and what type of paper you are using. Now, upon which factor they depend, it depends upon the that affinity, that solubility factor. So there is no problem in experimentation described above, because the mixture and the individual dyes were all put on the same piece of paper. The lid was closed on a very proper time, and affinity was also fine with it. If the mixture was put on one piece of chromatography paper and the individual dyes on a separate piece, obviously this activity could not be measured, because you're making the comparison. Now, you can still compare RF values as you can do on the same paper and the same solvent, but it is really recommended to perform this activity on the same chromatographic paper. Okay, so today we just covered chromatography, and at the end we just learned about RF vector. RF vector is something in which we can compare distance covered by samples to the distance covered by solvent, and at the end we can compare these distances. So by looking at these things, we can see that the one whose RF value is lesser has covered least distance basically. Okay, so that's it. See you. So basically, the RF value varies